Hello students, in this lecture I will tell you about the advanced encryption standard AES algorithm. So the first point about the AES algorithm is advanced encryption standard uses the non-fiscal structure. So in the non-fiscal structure we do not need to divide our plain text into the equal number of blocks. Also in the non-fiscal structure we carry only the invertible components. Another feature of the advanced encryption standard is the plain text block must be 128-bit. Also the cipher key must be 128-bit long. There are different versions are available for the advanced encryption standard. The first one is 128, 192 and the 256. So what are the difference in this version? That is basically the number of rounds, number of iterations that each version perform. Also in the cipher key as well as the plain text sizes vary according to the version to version. Just like in the AES 128-bit version, it uses a cipher key of 128-bit as well as the plain text block of 128-bit and the number of rounds is 10. Also in the version of AES 192, the number of rounds is 12. The plain text size must be 192-bit as well as the cipher key must be 192. The last version AES 256 uses 256 plain text size, 256 cipher key size as well as the number of rounds as well as the iteration uses the 14. The another important feature of the advanced encryption standard is unit, that is called state or the word. Means we have to represent our plain text bits into the form of state or the word. So how can we change our plain text bit block into the state or word? I will explain you with the help of example in some another time. So what is the structure of the AES? And the structure of the AES is divided into two parts. The first one is called the pre-round transformation and the second one is called the rounds. So in the pre-round transformation we just have to add the round key into our plain text. And what about the round structure? The round structure will carry the four type of transformation. The first one is called the subbytes. It is used to perform the substitution at the byte level. The second one is called the shift rows, in which we have to perform the permutation of the bytes, means the shifting of the bytes according to the row positions, according to the row position numbers. The third one is called the mixing. Mixing is used to perform the diffusion to the AES algorithm and it is achieved by using at the column level, and it performs a transmission known as mixed columns, in which we have to perform the multiplication to a plain text state to the constant column matrix. So what is the procedure? What will these transformations are done? I will elaborate you with the help of example. Just listen for the basic fundamental information. And the last transformation of the AES algorithm rounds is the add round key. So add round key is just like the previous pre-rounded transformation, in which I have to add the round key state into the plain text state. So this structure of AES can be understood like using this way. Like this is my 128-bit plain text. In the 128-bit plain text is fed into the pre-rounded transformation. So before going to the pre-rounded transformation, 128-bit plain text is converted into the state. After this pre-rounded transformation, when the pre-rounded transformation in the form of add round key is finished, then round 1 is serviced, and after the round 1, round 2 is serviced, and after finishing all of the rounds, the ciphertext will be generated. And the round key is also 128-bit. So my plain text is also 128-bit and the round key is also 128-bit, and there is a key expansion algorithm in order to generate the round key. So there is a specific procedure in order to generate the round keys, that also I will elaborate with the help of example in my later sections. Also the structure of each round can be understood by using this diagram, in which this is the state. What is the state? I will elaborate just after a few minutes. So this is the state is basically the representation of plain text. So after making the state, this state will go to the pre-rounded transformation. In the pre-rounded transformation we have to add the key. So after the pre-rounded transformation, one state is generated. This state will be act as an input for my rounds. So this is the round 1, in which we have to perform the first transformation, that is called the subbytes. After the subbytes is performed, another state will be generated, and from the another state it will go to the shift rows, in which I have to permute the state rows position according to the shifting, and another state will be generated. This state will be go to the mixed columns in order to apply the multiplication algorithm over the column matrix to the state matrix, and at the last we have to perform the add round key again, just adding the round key to my state matrix. So this state is basically the unit or the representation of the plain text block in the terms of input and output. So what is basically the state? In order to understand the state, we have to first understand the plain text representation. So how can we represent the bytes? A byte is a combination of 8 bits. So we can represent it by using the B0, B1, B2, B3, B4, B5, B6 and B7 and so on. So if my plain text is 128 bit, then in order to convert it into the number of bytes, we have to divide it by 8. So 128 divided by 8 equal to 16 bytes. Means I can represent my plain text block, that is 128 bit, into the 16 bytes. So this is the block B0, B1, B4, B5, B6, B7, B8 to B15. So in order to represent in the term of the state, we have to select the byte levels. So first this B0 will be placed here. Now we have to start from the B4, like B0, B1, B2 and B3 and B4, B5, B6 and B7. So in the state there is also a term called word. So what is word here? So word is a group of 4 bytes. So here B0 to B3 they are 4 bytes. So these 4 bytes is termed as word 0. This B4, B5, B6 and B7 represented as word 1, word 2 and word 3. So in the first matrix, it is a matrix of 4 cross 4, because we have 16 bytes here. So 4 number of rows and the 4 number of columns here. So the first byte of the word 0 will be placed here, like 0, 1, 2, 3, 0, 1, 2 and 3. And again the first byte of second word will be placed here. Third byte of first byte of the third word will be placed here, and the first byte of fourth word will be placed here. So like in this way we have to fill all of the entries. In the more simplest way, you can fill by using the sequential order, like B0, B1, B2 and B3. So B0, B1, B2 and B3 can be represented like there. Then B4, B5, B6, B7, then B4, B5, B6 and B7. Like in this way you can represent all of the block values in the term of bytes in the form of state representation. So it is very, very simple. In order to represent your state transformation of 128-bit plain text, first you have to convert your 128-bit plain text into the bytes. Then you have to convert in the form of states by using the sequencing order, like B0, B1, B2, B3 have to be placed in first column, B4, B5, B6 and B7 have to be placed in the second column, and so on. Otherwise you can use some equations also, like particular block I will be placed into as I mod 4 comma I divided by 4. Like if I want to place my B4, so what is the value of I equal to 4 here. So as I mod 4 and 4 divided by 4. So I mod 4 is 0. So as 0 and 1. So 0 and 1. Like in this position my B4 will be placed. So you can use the formula, otherwise you can follow some sequential procedure, like fill the columns of your matrix in the byte sequential process. And also the sequence of 4 bytes will be act as a word. Now this can be treated as, this B0 to B1 can be treated as a one word. This is another word, this is another word, and this is another word. Now this state can be represented as W0, W1, W2 and W3. Okay, so So now come to this transformation description. The first transformation in the AES algorithm is called sub-byte transformation, which is used to perform the substitution of the bytes. So what is the state? It is clear to all of the students. So this is the state which is built from the byte representation of the 128 bit. So from the 128 bit, this state is converted. So these sub-bytes transformation is a 16 independent one-to-one transformation. Like we have to select one of the state byte, and we have to divide it into two things. The first one is the row and the second one is the column. We have to look up in the table, and according to the table value you have to fill into the another new state. So according to all of the 16 independent transformations, a new state will be converted. Now the shift rows. The shift rows is basically something different from the previous shift rows and the permutation. So in this we have to shift the bytes according to the row number. Means if we have a row 0, the starting number is 0. So 0, 1, 2 and 3. So according to the row number we have to shift the byte. So if there is a row 0, then there is no shifting have to be performed. Otherwise, if there is a row 1, then we have to perform 1 byte shift. For the row 2 we have to perform 2 byte shift. For row 3 we have to perform 3 byte shift. And this shifting has to be done from the left shift towards. Now the mixed column is used to perform the diffusion. So we have to maintain a constant matrix here. This constant matrix is fixed in the AES algorithm, and I will tell you about the constant matrix multiplication in a brief way in my next video tutorial. So this is the constant matrix, and this is your state representation of 128 bit block. And after performing the add round key and the subbytes and the shift rows transformation, this state is created, and this state will be multiplied with the constant matrix, and after the multiplication new state matrix will be converted automatically. So the last structure of the transformation in the AES algorithm in the round is add round key. So it is very simple, just perform the addition of the two column matrices. So we have to select first column from this state, and we have to add from the key matrix, and another state will be converted. So don't worry, I will elaborate these things with the help of example also. So these are the basic things about the AES algorithm. So in the structure of AES algorithm, we elaborated all of the terms, like the pre-round transformation is just like the add round key. What are the round structures? What are the 128 bit plain text? What are the states? What are the word transformation? But one thing is remaining, is called the key expansion process. That from the cipher key, how can we generate the round key? The key expansion process I have to be elaborated. So in the key expansion process, that is very simple but some tricky. So with the help of example I will elaborate you the key expansion process. Just understand the diagram, so we can understand that our cipher key is 128 bit long. So in our previous like this one, you can see here that my plain text is 128 bit. Also my cipher key is also 128 bit. Means like the plain text, as we convert it into the form of bytes as well as states, we can also convert our cipher key into the number of bytes as well as the state. So like the same procedure I have to follow by converting it. So this is my cipher key in terms of bytes. So when I convert 128 bit into the byte, it will be converted into the 15 bytes representation, and each 4 sequence of bytes is called as a word. So K0, K1, K2 and K3 will be act as a one word, that is W0. K4 to K7, that will be act as another word. K8, K11, that will be act as a W2 word, and K12 and K15, that will be act as another word. So please remember, word is a sequence of 4 bytes. Now in the key expansion process, my cipher key is given. So before the cipher key, just understand the diagram. What's the diagram says? The diagram says that for the pre-round transformation, what was my pre-round transformation? In my pre-round transformation, we have to just perform the add round key transformation. Means we have to just add our key value into my plain text, and this key value into the matrix format, state format, as well as my plain text bit is also in the state format. We have to just select the column from the from the key matrix, as well as we have to add the key and just convert the another state, and this state will be act as input for my round 1. So this will be act as a round 0, that is called the pre-round transformation. The pre-round transformation, the round key will be act as it is without needed any further procedures. So directly from the cipher key, my pre-round transformation key will be ready. So W0, W1, W2 and W3 will be act as a pre-round transformation key. Now there is no difficulty for the pre-round transformation key, because the round key will be as it is from the cipher key, but difficulty begins from the round 1. When the round 1 begins, we have to generate one special round key. So what is the procedure in order to generate the round key? We will see this. So like in this table, we can say this is the table here. So in this table you can see this is a pre-round transformation. The first word is 24, 75, A2 and B3. Okay, 4 bytes. Then second word will be 34, 75, 56 and 88. Third word is 31, E2, 212 and 00, and fourth word is 13, AA, 54 and 87. So my pre-round transformation will be begin successfully and will be finished. What about the round 1? Means we have to generate the W4 value. So in order to generate the W4 value, we have to follow some specific procedures here. So what are the specific procedures? I will elaborate you. So in order to generate the further rounds, we have to check 2 rules. We have to follow 2 rules. We have to check 2 conditions. The first condition is if I mod 4, I is the word value. If I mod 4 is not equal to 0, in this case my Wi will be Wi minus 1 XOR Wi minus 4. Means we have to perform the XOR between the left hand side word value and upper word value. And the second case is if I mod 4 is divisible by 4. In this case equal to 4. If it is divisible by 4, then the value of Wi would be Wi minus 4 and XOR Ti, where Ti is the temporary word. So I will elaborate you with example, so don't worry, just please listen. So what is the formula of Ti here? So the Ti is, we have to select the Wi minus 1 value, means left hand side value. We have to perform the rotation word operation. I will elaborate all this, please listen carefully. So root word, then subword, and after the subword we have to perform the XOR with archon I. So what is the root word here? The root word is used to perform the rotation of bits 1 left hand side, means shifting of the bits 1 left hand side, only the one time only. Then what about the subword? The subword is used to perform the substitution by using the S box table, just like the sub bytes. So this is called the shifting by 1 byte, and this subword is perform the substitution. And what is the archon I? This is in the more defined way, that is R like R, con and I. So this R, con, I is called the constant values. These constant values are fixed in the AES algorithm. So R, con, I, according to the constant value, I have to make the XOR with the value manipulated from the root word and the subword. So now it's time for do some examples over it. So for the examples, I am taking some values. So now you can see these are the R constant values. Okay, and these in this diagram you can see there is a wi minus 1. So for generating the temporary word, I have to perform the XOR with R, con, I. This from the constant matrix. We have to select wi minus 1, then we have to perform the shifting of the bits, then we have to perform the substitution, and according to these values we have to perform the XOR with the R constant value, and my temporary word, that is Ti, will be created. So from the multiple of it we have to perform this functionality, otherwise you have to perform just the XOR of the upper value as well as the left hand side value. So now take the first example. So from the example you can just understand it by in a simple way. So what is the first example? The first example is in the pre-round transformation already W0, W1, W2 and W3 words are generated. So for the round 1 we have to generate the W4. So what will be the value of I? The value of I is this one, that is 4. So we have to check that I is divisible by 4 or not. So here is the condition. If I is divisible by 4 means second one is true, then we have to perform wi minus 4 XOR Ti. So what is the wi minus 4? 4 minus 4 equal to 0. So what should be the value? W0 XOR Ti. Okay, so what is the value of W0 here? So W0 value is 24, 75, A2 and B3, means the left, the upper side value, wi minus 1, the upper side value. So we have to generate the Ti value also for performing the XOR. So how can we generate the Ti value? In the Ti value we have to select the wi minus 1 value. What is the wi minus 1 value here? 4 minus 1 equal to 3, means W3. We have to select the third this word W3, means 13, AA, 54 and 87. So just write down 13, AA. I will elaborate you more example, like I equal to 4 here. So what is the value of wi? I have to select wi minus 1, this one. So wi minus 1. So what should be value? W4 minus 1 means W3. I have to select W3. What is the value of W3? W3 value is this one. So 13 AA 5487. Now what is the second task? The second task I have to perform the rotation, means shifting. So perform the shifting, that will be AA 5487 and 130, because this will be act as a 1 byte. 13 is a 1 byte, 54 is a 1 byte, 87 is a 1 byte, because each word is made up of 4 consecutive bytes. If there is a 4 consecutive bytes, means each having 2 bit words. That's why we have to perform the byte level shifting, means we have to select 2 bytes at the time. So AA 54, 87 and 13 is the answer after performing the shifting. Then the second one is we have to perform the subword, means the substitution of the bytes by using the S box table. So these are the sub bytes transformation. I already pasted it. So I have to just find the value of AA. So what is the value of A in the table? The value of A is A and this one A. The value of A is AC. So write down value of AA is AC. Then again, what is the value of 54 in the table? 54, 5 and 4, 20. So write down 20 here. Now Again the value of 87 and 13. Value of 87, 80 and 7 is 17, and 13, 1 and 3, 70. So 17 and 70 is the answer. 70 and 7D. Now these two transformations are finished, means rotation and the subbytes. Now we have to perform the XOR with I divided by 4. So what is the value of I? I value is 4. So 4 divided 4 is 1. So R con 1 here. What is the value of R con 1? For round 1, R con 1 is this one. And you have to perform the XOR with 0 1 value. So how can we perform the XOR with 0 1 value? So 0 1 0 0 0 0 0 0 this one. 0 1 1 2 3 4 5 6 1 2 3 4 5 6 7 8. Yes. So what should be the answer here? The value of answer is C plus 1 is, what should be C plus 1 is D. C. What is the representation of C? 1101, in which I have to add 1 value. So 0 0 1. What will be the value? 1101. What is the hexadecimal equivalent value? That is D. So answer is D here. Then 2, then 0 and 1, then 7 and 7 and D. So this is your final answer of the T value. So my T value is, I am getting my T value. Just write here W4. What is the value of WI minus 1? So the WI minus 1 value is 13A 5487. 13AA 54 and 87. What is WI minus 4? So WI minus 4 is W0 2475 A2 B3. 2475 A2 and B3. So WI minus 1 XOR WI minus 4 is not necessary. What is the root word answer? The root word answer is this one. So this is my root word answer. Then after performing the substitution of the bytes, what is your answer? Answer is this one. Then after performing the R con value, what is the R con value? R con value is 0 1. Paste it here. Then TI value, the temporary word. The temporary word value is this one. And now I have to follow the final thing. What is the final thing? If it is divided by 4, then we have to perform the XOR with TI. WI minus 4 XOR TI. What is WI minus 1? Minus 4. WI minus 4 is 2475 A2 B3 with the value of TI, means this one. So perform the convert into the binary form. So what should be the equivalent of 2? 2 is represented by 0010. 4 is represented by 0100. 7 is represented by 0111. 5 is represented by 0101. 8 is represented by 1010. And 2 is represented by 010. B is represented by 1011, and 3 is represented by 0011. Now what should be the binary equivalent of this TI? This one, this TI. So this TI is 1010. D will be act as a 1101. 2 will be 0010. 0 is 0 0, 1 is 0 0 1, 7 is 0 triple 1, again triple 1, and D, that is 1 1 0 1. Now perform the XOR between the two, that is 1 0 0 0 and 1 0 0 1 0 1 0 1 0 1 0 1 1 0 1 1 0 1 1 0 1 1 1 0 0 1 1 1 and 0. So what should be the decimal equivalent? Sorry, hexadecimal equivalent. Wi minus 4 XOR Ti. For the W or XOR Ti should be 8 9 5, then again 5, 1 0 1 1 is B, 5, then it is C, and this is A. So my W4 value is 8955 B5CA. Right here W5 value is 8955 B5C and A. So now the W4 is finished. What about the W5? So what should be the value of 5 here? I equal to 5. Now check it is divisible by 4 or not. No, the first condition is true. So I have to perform the XOR with Wi minus 4 XOR Wi minus 4. Means we have to perform the XOR between the upper words value as well as the left hand side value. So in this case, so now again I have to calculate the value of W5. The W5 value is I equal to 5. So now you can check the 5 is divisible by 4 or not. It is not divisible by 4. So the first condition is true, in which I have to perform the XOR between Wi minus 1 XOR Wi minus 4. So Wi minus 1 is 5 minus 1 equal to 4, means W4. What is the value of W4? That is 8955 B5CE. And what is the value of Wi minus 4? Wi minus 4 is 5 minus 4 equal to 1. So W1 is 34 7 5 5 6 8 8. So these are the equivalent Wi minus 1 value, and this one is Wi minus 4, and I am performing the XOR between the two, and this I got this answer. So what should be the hexadecimal equivalent? 1011 is B, then 1101 is, that is D, then 0010 is 2, then 0, 1110 is E, 0011 is 3, 0100 is 4, and 0110 is 6. And these things will not be performed here. It is not essential. So what about the W6? My W5 is already finished. So what about the W5? My W5 value is BD 20 E3 and 46. So what about the W6? 6 is divisible by 4 or not? No. So first condition is true, in which I have to perform the XOR between Wi minus 1 and Wi minus 4. So what is Wi minus 1? 6 minus 1 equal to 5. So what is the value of 5? That is BD 20 E3 46. And 6 minus 4 equal to 2. So what is the value of 2? Is this one, that is 31 E2 1 2 and 0 0. I have to perform the XOR between two values. So this W6 already done. Now the decimal binary equivalent of this one, 3 1 is 0 0 1 1 0 0 0 1. E is 1 1 1 0, 2 is 0 0 1 0, 1 is 0 0 1, then 0 0 1 0 and 0 and 0. So what should be the XOR? That is 1 0 0 0 and 1 1 0 0 1 1 0 0 0 0 1 0 triple 1 fourth 1 0 0 0 1 0 1 0 0 and 0 1 1 0. So what should be the hexadecimal equivalent? That is 8. 1 1 0 0 is 4, again C, then 2, then F, then 1, then 4, and this one is 6. So now in this term my W6 value is calculated, that is 8cc, 2F, 146. So like in the same way we have to calculate the value of W7. So now you can see I have calculated the value of W7. So these are the procedures you have to follow in order to generate the round keys. So from this W5, W6 and W7, my first round key will be generated, which will be used to complete the round 1. So as per this following conditions and the following procedures, you have to just generate the round keys. So this is the round 1 key generation. So according to the same procedure you can generate another round keys. And the one thing you have to just take care that if the number, the I value is divisible by 4, or this is a multiple of 4, like 4, 8, 16, 24, then you have to use the temporary word procedures. Otherwise it is not needed. You have to just XOR the value of the left hand side value as well as the upper value, left hand side value and the upper value, and perform the XOR, and you will get the answer. So this is the procedure you have to follow in order to generate the key for the round generations. Hopefully it is very clear to all of the students. If anyone has a doubt, then please let me know in a separate email, and the example of AES algorithm I will elaborate you in my another video tutorial. So please watch my video. Thank you.